SuperMap products. So today we have 4 parts for this presentation. First, I will introduce you the iServer and iPortal and show demos for with iPortal and iServer. It's called COVID-19 dashboard. And I will introduce you the iClient for JavaScript and iClient 3D for WebGL and how to get started a project with iClient for JavaScript and the WebGL project. So first part is the iServer introduction. So this is what is GIS servers plays a role with in the GIS application. So GIS application can retrieve the data source, so REST API from GIS server, and SuperMap iServer can publish diverse services like basic map surveys, data surveys, or geometric surveys. We also can publish 3D surveys, spatial analysis surveys, and other OGC surveys or network analysis surveys. And due to the big data management requirements, we also can publish the distributed analysis surveys and the streaming data surveys. In the 10i product, we added machine learning surveys and data science services for AI functions. So SuperMap iServer is the most popular product in SuperMap product family as its strong functions and high performance also provide distributed functions. It's also very stable and reliable. So what is GIS services? And for like map service, we can browse the map and zoom in or zoom out, edit the map on the website. Also can do some map measurement, map query, or also can do the thematic mapping. And what is the data services? Data services can meet the requirements about the data querying, data sources or data sets, and also achieve the online editing, and you can edit the data online. Also can add the object or delete or modify the object data sets. And the spatial analysis service, and we have the keep, erase, or delete some spatial analysis in iDesktop, but also can do it in server side. Also network analysis includes optimal path analysis, traveling salesman analysis, or closed facility analysis. Yeah. And for some industry functions, and we could support the traffic analysis and address services. Now we provide the address service for Chinese government, but we also we can publish the address service in your own country if we have the data. And also 3D services that can achieve the browse the 3D models in server side in website. And so we have to publish 3D services. Also can publish 3D network services that can achieve the pipeline analysis, like burst analysis in server side. Also geometry services can achieve the measurement of the data of the whole thing as well. And what is GIS Service Plus mean? And so for those basic geospatial surveys, we also can provide some services for big data or AI functions, like for the distributed analysis service can achieve the distributed map visualization and distribute cluster based on Spark and that improves the rendering performance of the high volumes of spatial data, and also data catalog service to manage the big data, and also achieve the real-time data service to achieve the real-time visualization of geospatial data, and data stream services with WebSocket. So this is a workflow of the SuperMap iServer streaming data source. So this is our streaming data sources. The sources could be from multi social media or sensors or RFID or airplane, something like that. We can retrieve the data through these sources, and we could input this source data to our server side through spatial filtering or attribute filtering that can publish as a service streaming data service. Then the results, the services could be visualized in desktop side, mobile side, and the website. And also in the meantime, the real-time data could be stored in the SuperMap iServer data store. So in this whole flow, we will use the SuperMap 10i technology. Also, we will rely on sparkling streaming data technology with Elasticsearch for big data management. And here is an example of the streaming data visualization of this is global flights track. We can know its track points, track lines, and also you can see the time, the real-time time, and also if you want just to query the specific date and the specific time and a special region. Yeah, this also is super data big data. Just for IoT, it's similar with that, and also for we have the machine learning service. This is an example of the machine learning service, and we could do the machine learning service that we can do the model training in iDesktop X through multiple iteration, and we can get a AI model. Then we can publish the model in SuperMap iServer and achieve the reasoning and predicting in servers in website. And this is an example that we can do the binary query, binary classification in server side. And this is a screenshot of the SuperMap iServer, and we can manage. You can see we manage the server performance and the cloud server load, and get the server success statistics to monitor the server performance in real time. And in addition, and because there a lot of industries, they have the very rich requirements based on their own industry needs. So we also supported customized GIS service with extension development. So we allowed to construct the industrial service components for all service layers, and the development kit, we can realize the dynamic linkage and integration of service layers, and we also manage customized services easily with microkernel technology. So where we can download the products, the iServer. So we can, of course, we can download the software in our offshore website. And here are the 4 types of the product package. You can select the one suit your needs. Usually, because I prefer the deploy package. Then this one you don't need to install the software and you just use and it's very light package. But if you want to more help information, I suggest you to download the install package or zip package. The difference between them and for install package, then you need to install the software. Then there will be application in your iServer application in your software. And if you download the zip package or deploy package, then you don't need to install it. You just start up. And for work package is for special use. So I don't suggest to you try it now. And for then next part is iPortal introduction. So what is SuperMap iPortal? So iPortal that we usually use it for manage the multi-resource and data resource and manage the multi-users. So for resource, what we could do for resource management, and we could share the diverse data to others and integrate data in one portal. And also we can achieve the user management and the role management, user authentication, authority management in user center. Most important, we have the applications center, and now we have the database, data insight dashboard, SuperMap IOs, and more application will be added. And also this iPortal is also works based on SuperMap iServer. Sorry. So this is the new our portal homepage and the resource center and management. And this is, and also the portal application also can be adapted for multi-terminal. Also, if you have the application and create application, this also can work done and can be displayed on the mobile side and without any codes. And here this is portal platform, and you can create your portal website without any code. Also create a web application and sorry. So here's some examples of the portal customized portal application with SuperMap iPortal without any codes. And also here is we have the user management, and you can add different users in different departments and give the different rights for the different user in different level. So it can achieve some organization management. So the database, now we have 3 web apps called database, data insights, and 3D Earth map dashboard database that you can create your create your thematic map on the website, and it provides many default styles and data insets. If you can create different visualization styles, like we use different charts to represent your data. Also for dashboards, create our own dashboard without any coding in SuperMap iPortal and 3D Earth, and we use integrate SuperMap IRs with Portal. That you also can create your 3D application. So for this is a database. It can support streaming data and migration map. Provide them rich symbols and data insets. 3D Earth cool for 3D visualization. And this is map dashboard. Also can backend statistics. So now I will show you a demo at how to create a COVID-19 and COVID-19 dashboard for your own country. So before that, what we need to do? So first one, we need to process the data beforehand. And then you need to download the SuperMap iPortal, iServer, of course, iDesktop for data processing. And for the data requirements, of course, we need to have it because we will create a dashboard for COVID-19 distribution. So what we need is daily update of errors in each area, and also the mainstream boundary data. Then next is data visualization, also the making the dashboard. So like here's a case of the Uganda. We have to have the case or cases column, and this is a boundary for district or neighbors. And then we will achieve the data visualization in iDesktop, create a thematic map. And you also can create a thematic map in database. And then we will probably create a dashboard, use data, and we can add different charts to represent the data. Also, then here you can connect if we have the real-time data. Now we can add this real-time at this service URL in real-time data. And here, this is a case. This is a screenshot of the Uganda COVID-19 coronavirus dashboard. And you can see here is a map that published in iServer and added, displayed in iPortal. Also, we can add some text information also with some charts, line charts, bar chart. So to create such dashboards, you don't need to write any codes, and it also can be displayed in mobile site. So now I will show you how to create such COVID-19. Sorry. So first, we have to publish the iServer. We have prepared the iServer and iPortal. wait a moment. Wait me a second. Just wait a moment. So before the first step is to create the data, the coronavirus distribution data.
Hello, Amber, we can't see your screen.
Okay. Can you see my screen now?
Yes, you can continue.
Okay, so first we will create the data, open the vector data. Here is sample data for Guinea. Then we have created the total cases. Well, get the cases data from government, from official departments. Then we will create such geometry vector data. So you also need to prepare the administrative data, and here some cure data and some status data like top 10 data. And then we need to create a semantic map. How to create such semantic map for cases, and use different color means different scale. Create a range map, and you can set a different color table for your own semantic map. And also you can add the some labels after them to represent the district name. And you can set its font size and the font height for the same. Set font effect, font styles in iDesktop. Also, you can add the bubble map. So for the range map, to display the cases numbers in bubbles. Also, you can set a bubbles color into different color, and also we can add the word map as a background and set it in different colors to make it have a better visualization. Set it to black. This is base map of COVID-19 distribution. Then this is the data preparation. After we get this data, then we can save it. If we want to publish in iServer, so first we have to save it as a map. Then we can create, and we can publish the map surveys. Also, for this vector data, we can publish as a data surveys. Then iPortal also can retrieve this data information through data surveys. And for this is total cases, so we have the data date and the cases number information. So this is data preparation. So you can prepare data like this. And for these cases or Q number, then you have to prepare your attribute table. Then if we have already prepared the data, and then we can start to publish the data. So first let's start the iServer. So we here we just use the startup. Then you can start the iServer. It will take some time to start up the server. And also, if you want to shut down the iServer, you can use shutdown.bat file. And also, if you forget your password or username, you can use password reset. And here is the configuration information in server.xml. So for the server, you have the port number. Port number is the default port number is 8090 for iServer. You also can change it to others. So here is iServer is still loading, and when it can be finished, and you also when you see the iServer start up in this, then it means your iServer has started up, and then you can go to the browser and type the localhost. It's 090. That will go to the SuperMap iServer homepage. You can see we can publish OGC server. Then first you need to log in. But if you the first time to use the iServer, you have to set up your account. Set username and password. Now we will start to publish the services. We choose the quickly publish service and use the workspace, and to choose the workspace that we just created in the data preparation set, and then choose to publish the map service and the data service. So we got our map service and the data service. Here is a map, and you can see that we create a cases map in iDesktop, and we also can have a preview with the iClient for leaflet. Then we can, this is a preview of the map service that we published. Also the data service, and we can check the data sources and the data sets. And this is a data set in our data source. We also can see it in iDesktop. And then there is a note that you should be aware of. That if you use the UDB file, then if you already start up the iServer and publish as a services, then your iDesktop cannot check the UDB datasets in iDesktop. Then if you open the datasets or data source in iDesktop, but you also publish the data services in iServer, then it will be blank in your iServer side, so you cannot open the data both in iServer side and desktop side. But UDBX is okay. So we have already published the map service and data service in server side. So now we can go back to the portal. So for the iPortal, it's same. We have to start up it because it's developed based on the SuperMap server, and also it's the Tomcat. So we need to start up. And also it's same with iServer if you want to shut down or reset a password or user management. And also you can change the, we can check its default port number. It's 8190. So it was, but you also can change it due to your performance, but be aware of don't use the same port number for iServer and iPortal. Then when it's still loading, when we see the, it's okay. When we see the it's already start up in how many milliseconds, then the iPortal has started up. So this is a screenshot of the SuperMap iPortal, and we have the home page and resource center, app center, and this is apps, and you can create your apps and by click them, and also you can manage your home page. So let's get started. And you can go to surveys, resource center to manage all your resources, and you can publish the also create your map dashboard and add your own map service or data service in iPortal. So this is a database application that you can add your data service. And this is a dashboard that we created before for Geneva COVID-19 coronavirus dashboards. So it's the same, and you can see except the map service, other the layout is same with the Uganda coronavirus dashboard. So it's very easy to create. If you already have such designs layouts, then you just need to change the data. And you can create your own country's COVID-19 dashboard. So here I will show you how to create your own dashboard. So here just create you click map dashboard. Then here is a blank. Then you can, here's some template. You can use this template, or if you want to create your own design, then you just click the blank. First, we have to add the map service. So what is a map service? We have to click the services because we have published in iServer. Then we just copy this service link in select map. Select map, there's a service, then you can add this map. And also in this window, you can adjust the view extent for this map. And also we can add other charts, like say this line charts. Then here we can select the data. We update. This is the data services that we published in iServer. So we just copy this link, set the data source, set the data sets. So for URL, we have to follow the template that it stops at data sources and choose the data sets. Let's say we choose the cases top 10, and then we have to select the x-axis data and the y-axis data for different. So for x-axis data, we will select. We can select the and for y-axis we can select the date or region. Also then we can add a line chart for other data for other data sets like query data and cases top 10 for the whole cases trend. We can see the query data, and also it's same. You can adjust the x-axis or y-axis. So we have the query number, then we can see it goes down through the time, and also can add other data sets. So this for the daily cases, whole case for the whole country. So now we only have the chart, but we also need some description. Then we can add the text widget to input the description of these charts or this map. So after all of this, you added all the components of the dashboard, and you also can design your own layout to make a better visualization. So for this, if you want to create such dashboard, you don't need to write any codes. It's very easy to start to learn how to publish the service, to work on the web services, create web application. So after you finish, also don't forget to save your dashboard when you get progress. And after the design of the dashboard, then we can publish as a web application. So let's have a look of this dashboard. Yeah, this is a dashboard I created. So you can save it when you are doing the operations that will avoid to losing your work And when we publish, then we can go to App Center, then you can get your COVID-19 distribution map. This is for Uganda. This for I created before. It's very easy. Then you can check have the cases. Also, this is here is a project we have done for Geneva government, and it's also you can see its trend, the cure cases trends, and the trends in confirmed cases, and also here some information about the confirmed cases and the cases still in hospital. For map, you also can zoom in or zoom out. Also can add the logo.
Hello. Sorry, Amber. I think we can't see you.
Oh, okay.
It's
sorry.
just the PPT.
Okay, sorry. Can you see my screen now? For the now it's website, right? It's iPortal page. Yeah. So that's a dashboard layout. Here you can add the components, text, or other charts, and save it. Don't forget to save it and publish. And this when you save it, publish as a publish in iPortal, then you can see your works here. Then you can open it. And this is the cases for Geneva government that we have done for Geneva government. And here's some labels to just create a clear number to show the situation in Geneva now. And also you can add the logo for the government. So that's a demo for iPortal and iServer and how to create a COVID-19 dashboard. So let's have a short break. So the third part is the iClient for JavaScript introduction. So this is a SuperMap iClient for JavaScript. It's includes diverse map libraries like OpenLayers, Leaflet, and Mapbox, and also we integrate some data visualization libraries into SuperMap iClient for JavaScript, and then we also provide a lot of functions that based originally from SuperMap, like supports the iClient, supports the visualization of web service published by iServer, and also some spatial functions, spatial analysis functions. So we have for map libraries, we support the OpenLayers and Leaflet and Mapbox. OpenLayers is also very strong open source map libraries. It have a strong function, support vector layers and spatial analysis. And Leaflet is a very lightweight and mobile friendly map library. And we also have many libraries like D3 and eChart and MapV. And also we have a lot of sample codes for JavaScript it's also in our official website, and also if you download the iClient package, then also can go to your iClient package I will show you later. So what is WebGIS? That WebGIS can show, we can make use these libraries to make a web project to show all the geospatial data in server side and do the spatial analysis in server side and have a lot interactive. And how to select the map libraries? Because we have the leaflet, open layers, map box, also have the iClient classical, and so here are some indicators that we can considering. We can consider that the advantage and disadvantage, performance, stability, and so for the advantage, then leaflet has it's very lightweight, and for open layers now it's because it now it supports also integrate some functions from systems, so it will be heavier than others, but it also provide more functions, and also in 3D and the Mapbox GL, it has very good display visualization effects for vector tiles and have a lot of beautiful visualization styles. So iClient Classic, it has a larger user base and it's have a higher stability than others. So you can select if you want to try want to create a web project, you can select any of them due to considering of these indicators. I usually use open layers and leaflet. And here also then we have the basic libraries that we talk, map libraries, but we also have the supports diverse visualization libraries like Map3, eCharts, D3, 3JS, Heatmap.js, Cattle that can help us to make our map more beautiful and dynamic and more interactive. So here's a case of a leaflet and a Map3. So Mapbox, it's a dynamic. All of these are dynamic. It's a flights, dynamic flights. Use leaflet plus eCharts, and this is also a Mapbox with eCharts effect. So we combine these map libraries and the visualization libraries. We can make more possibilities for geospatial data visualization. So now I will show you how to get it started with iClient for JavaScript with an example of leaflet. So we will publish a JS data service and browse the service in the client set. This is a very easy demo. We'll create a web page to browse such map. So first step, we have to prepare the spatial data. Then we'll publish as a service, map service in iServer. Then we'll write the code and visualize published web system in browser. The first step, we will prepare the data. So we already have, like say we will create a map and save as a workspace in iDesktop. Create the China map. Also can create. Then you can. This data is if you download the iDesktop, then you will get a sample data package. This China map and the world map are included in the sample data package. So next step is to create iServer service. So first we have to realize that, beware of the what map service that we should publish. So I introduced before in iServer part, we have the map service, data service, 3D service, geometric service. So what is the service map we should publish? If you want to have a map visualization, just to have, you want to create a map and just publish, visualize the map on the website, so just to publish the map service. So if you want to do some semantic mapping or semantic map, or edit some data, or create do some operation with vector data, that you have to publish the data service. Also, if you want to see the 3D buildings, then you have to publish 3D service. If you would like to do some spatial analysis functions, then you have to publish spatial analysis service. So for this, getting started, we will start how to publish map service. So first we have to we decided which service type that we should publish. Then next step we will start the iServer. We will run the startup under the bin folder of the iServer directory, and create the iServer service. So this is a step to create the iServer service. First run the startup, and also you have if you use install this package, then you have to follow the second method to start and choose from your SuperMap iServer application, then choose the start iServer service. Then you will get this window, a black window. Then when you see this server start up in how many milliseconds, then your iServer has started up. Here we quickly publish service and choose the workspace that we created, and we will select the service that we want to publish. Here we will select the REST map service. And once we have published the service, we will get a preview of the service on iServer side. So here we can view with iClient, the JavaScript for leaflet. Now we can get a preview of this service. The next step is to create a project. So first we have decided which development tool that we want to use. So here we will select the SuperMap iClient, then and we'll use Leaflet as our map library. Yeah. So we will download the iClient package, then put the iClient package, project package in iServer. And then here is you can create a getting started folder and you have to copy the library files to the new folder, but also you can use, if you want to start easily, you can just use iClient folder. And then you have to create a HTML page, blank HTML page that includes the head and body part. For head part, you can define the title of this HTML page. and also the map data, you have to claim that the map data to have to notice that you have to set the char set to UTF-8, otherwise it have a problem with the visualization of your words. And then we have to add the script library reference. Because we use leaflet. This is script library, and then we will add the div, the element for map window. So here we will create a div for map, set its values and height. Px is pixel, means pixel, and add this pixel. And then we will add the map layer. We already have the element for map, div for map, so now we have to create the map element with leaflet and set the properties of this map element. So this is variable map and the layer, because we have the map element, then a map could include several layers. And this one here, this map is, we have the map div and leaflet at dot map to create a map object and set its zoom level and the original zoom level, also set its coordinate system. And this URL is for the map service. We will add this map service to the map object. So this is our leaflet map object. Then we can add the map layer. Use l.supermap, this API, and .tilde map layer URL, then and add this tile map layer to this map object. This is how to add iServer layer to map. Then after that, you create the web page, the HTML page. Then you have to put your project folder under the web apps directory of the iServer. Then you can start debugging using this link. So let's go see let's see a demonstration of the how to can you see? So first is data preparation. Let's open the data, the China map data. You can download this data in our official website, and you can see then open the map. It already created beforehand, and this is map, China map. Then we'll save it as a workspace. So this is data preparation. After we prepared this data, we can publish. I'll go to the iServer. Service management. Click service management. We need to log in again for SuperMap. And also can click the remember me, then you don't need to log in every time, and click quickly publish service and select the workspace that we stored for the China map in sample data. China, and select workspace, then next to select the map service. Next, finish. So here we published the China map service, and here are 3 maps, and we could have a preview with leaflet of the map service. So we can get to the China map service. And next, we will go to we need to create the HTML page. So before that, so let's have a look. The SuperMap iClient package. This is a SuperMap iClient package. It includes 2 parts. One is called dist and examples. For dist, it includes all the libraries for leaflet, for let me see, can you see I want to share my software in. Yes. So this is iClient package. If you download from the official website, then you will get this package. So in the dist, it has the source code for leaflet for Mapbox OL open layers. OL is just for OL2, and open layers for open layer 3 and 4. And some classical source codes. So if you want to create any project with iClient, so don't forget this. Please copy this dist folder with your project. Also, then we can check our examples. Here is a lot of the examples for open layers, Mapbox, leaflet, and also have some JavaScript file and CSS file and some the data needed in the example. So here I suggest you to use the Visual Studio Code because it's a very light, this one, Visual Studio Code. It's a very light coding tools, and it's for free for coding, and I like its coloring. Its style for codes is very clear, and also have a lot of quick debugging tools. So it's very user friendly for web development. So I suggest to you choose this. And now here we can create. We got examples. So we have found the leaflet examples. If we want getting started with leaflet, getting started with development with leaflet, and here we can select create a getting start HTML like I showed in the slides. First, at the HTML page includes the head and the body part. So in the head part, you have to claim the chart set and give a title, and also add the required reference and JavaScript reference file. Script file here has to include the web. It has include some.
Oh, and we can't see your screen.
Okay, sorry. I'm sorry that because it involves multiple windows. Sometimes I forgot to switch the window. So this is sorry for that. This is a Visual Studio window that we can write code in this software. It's a very user-friendly software. Then here we can see the leaflet examples, and here a lot of examples. And if you are not so familiar with JavaScript, then you can follow these examples to start learning the JavaScript and get familiar with APIs. And yeah. So this is we have started the getting started page. So it includes, like say, the HTML page. It includes the head part and the body part. In the head part, we can claim. We can claim that we need to set the title and add the script, necessary script files, libraries. Here, we put some necessary JavaScript files in such folder. And here also we have the body part. Body part, we can set its style, margin, overflow, and background. This CSS style. We also can add the CSS file in the head part. That you don't need to write this CSS code in here, so it depends on your own performance. Then we have to create a div for map. So this is a window for map, and give it ID. And also for this part, because we have to use a leaflet library. I have to use its leaflet API. So I have to, don't forget this, to add the reference files in body parts. And also now we will add the script codes in script part. We have to claim two. The first variable is called map. The map object is important, and we can specify that map element and map object with a leaflet. And also this URL is a service, map service that we published in iServer. So first is then if we have claimed the variable for the map, we have create the map object, use such API l.map. And then this is the div ID for the map, and set a center, and the max zoom and the min zoom level. Also the original zoom level when we open the map. So this is map object. Then here, this one is l.supermap image layer, image map layer, tile map layer. So here we can add the image map layer and use URL, this service address, and we can set its transparent false. You also can here. This is not necessary, but if you want to set its style, you also can set it. Then I have to, we create a map layer, use this code. Then after we create this map layer, we have added to the map objects. So that's a getting started page. It's very simple, and then we can run it in browser site. So this one, if we is the examples page for iClient. So you can explore many examples. This link. Yeah. This is a getting started page that we created. Just go type this link, localhost, and the SuperMap iClient examples, leaflet, get started, .xml, and we got our own web page. So this one is very easy. It's a demo for iClient for JavaScript. So, but it's a very easy examples. Here you can see there are many examples for different functions. So it also includes how to add the different map service with different coordinate system, and also can add vector tile data, and you also can do some geometry query if you publish the data service. Also do the circle query, and you can achieve the measurement for distance and area. And for the data service, you can also edit. So online editing of the data service and a different query. So can do the semantic map service. Create a semantic map used with iClient, set different styles and different map styles. This is for spatial analysis, buffer analysis, overlay analysis.
Amber, we can't see it.
I'm really sorry. I don't know whether I need to. Okay, I should select this. Yeah. So this is iClient. iClient iClient page that we can explore many functions, many examples. So for this is for map service, data service, and the semantic map service, spatial analysis service, and network analysis. You can check the its codes in code editor to see how you can achieve how this works, how these projects works, and try these examples by yourself. I don't know whether you have seen the getting started. Let's see. SuperMap. iClient. Getting started. So that's a map service that the getting started page we create here. So this is a very original demo, or the first step to learn iClient. So you can explore more functions to learn these demos, to learn these examples. Also, for the same method, you can try to work with open layers or Mapbox. So for open layers and leaflets, they have the similar, for the basic function, they have a similar capability. Yeah. So I think that's all for the iClient for JavaScript. So now let's get started with iClient 3D for WebGL. So what is iClient 3D for WebGL? It's also a 3D libraries, JS libraries. It's developed based on CLM, and it can be worked in different browsers and different terminals. So you also can view your 3D project in your mobile phone. And it's a very lightweight, and you don't need to install any plugin. So before WebGL technology, if we want to create a 3D web project, we have to install different plugins. So it will be not so easy to use. And so with the WebGL technology, it's very easy to develop the 3D object, web object, and also very easy to extend for extension, and you can develop your own API and your own functions for your own requirements. And this is screenshots of the iClient 3D for WebGL sample codes, and here is how to add the image layer, how to add a terrain layer and dynamic layer, how to add different 3D models, measurements, and 3D spatial analysis. So it's a platform and independent cloud.js network client for 3D data visualization and analysis. And based on the web technology, integrate a lot of map library and the visualization library. So if you want to create such WebGL project or 3D application, web application, besides iClient 3D for WebGL, what others you need to learn? So first, of course, iClient, SuperMap iDesktop, especially 3D designer, you have to build a 3D scene in iDesktop, and have to create 3D 3D tile data and catch data, so that can be published in 3D surveys. You can publish in 3D survey in iServer or iPortal. Then can develop the application with SuperMap iClient 3D for WebGL. So this is the product features. It supports a multi-source of the GIS spatial data, includes 2D vector data and 3D model data. And it also have the capability for massive data. Then now we support to visualize the city levels 3D modeling data, and it has very complete 3D GIS functions. So for the multi-source GIS spatial data, we can include 2D data and the 3D data, 3D max or beam model, or oblique photogrammetry model, point cloud, and the street view video. Or you also can connect with Internet of Things. And also we support the 3D particle effect like firework or fountain also can add and supports the visualization of the volume data that could be used for radio signal or other other data for representing the signal strengths. So for the layers, that type of layers that we have the topography layer and image layer for the global surface, terrain layer, and S3M layer, KML layer, and dynamic layer. The next capacity of the massive data. So for the topographical terrain and image data, we can suppose is the data at TV level and support the vector ground features. The building data, more than 10 million objects. Also, that can see the city level models over than 400 square kilometers. Also support the oblique photogrammetry model at TV level and loading and display of millions of the pipelines data. And of course, the most important, we have the very good performance at browsing of the virus things in different scales of scale or urban planning model and indoor models. And this is here, then we can see the dynamic layers that these examples is global shipment data. Can see we can visualize the whole global shipment movements, and this is for whole global flight with 3D model, and this is 3D airplane model, and this is a terrain model. Also have the flat, the oblique photogrammetry model. It's a flat simulation. It simulates a flat. What if there's a flat? How it will affect the city. Also the beam, and we can manage the beam, the visualization and manage the beam model in WebGL platform, and you can check and browse system models in different type by different type, and check the every model's information. Also, you can search the models by the keyword, and then you can go to the model's location quickly, and also can set the model's styles. You can set the transparency of the models. Now also you can set emergency plan, fire plan. And this is point cloud data. With supports the visualization of the massive point cloud data. So before we will start to the WebGL client, what we need to know is about S3M. It's called Spatial 3D Model. It's a 3D spatial data specification, and that it's a standard 3D format in China. So what's the advantage of this format? Then we provide the data specification of massive 3D data. So it has a very smooth rendering performance for massive 3D data, and with high efficiency in transmission and render and analysis. So can forming comprehensive application solution. So S3M is developed by SuperMap, and for the other 3D data standard, we also have to know OSGB and the 3D tiles via OGC data format. But for for OSGB data, here are some disadvantages. So it has a low performance and rendering performance for big data, and it will cost a long time to parse the model, and also have the weak in the it cannot be displayed in the web platform. So if you want to visualize the 3D models, you have to use 3D tiles that's developed based on season. So what compares to 3D tiles and OSGB? What's the advantage of S3M? So this is his advantage. We'll talk about it before. It can support multi-source of data. It can be visualized in cross-platform and available in browser and mobile sites. It has a high data security and very easy to parse that will cost rendering time. So it achieves efficient rendering, and it's very easy transmission. So it can support massive data visualization on web platform. And why we have so efficient rendering? Because we also have you have made use of different technology like LOD and instantiation for data rendering. Yeah. Also can achieve the object selection and query for 3D models, and change the color styles of the models in websites, and modifies the visibility of multiple projects. So that's the data what S3M data supports. We have oblique photogrammetry model, manual model like 3D Max model or SketchUp model, and underground pipeline, beam model, point cloud, 3D field, and water surface. Those can create water surface in iDesktop. And fine model, that also manual model, also have 2D vector data. So OSGB can convert it to S3M, and S3M also can convert it to OSGB. S3D tiles also can convert it to S3M. So S3M layer also can improve the memory usage performance. You can see a memory use is reduced by 30% if you use S3M layer. Here are some examples. It's a dynamic modeling. It shows the dynamic modeling process of the 3D buildings. And this is dynamic layer for the fan. And so how can we achieve the interaction with server? So we will do the analysis. we will set recorder analysis functions in the front end and set the parameters of the analysis. Then we will do the calculation in server side and display the analysis results in front end so that the calculation in server side has better performance than calculation in front end. Let's see, this is spatial query, and we can search so we can query the objects, so the circular query and the spatial query. Here's some 3D spatial analysis, like we talk the visibility analysis, sightline analysis, shadow analysis, and skyline analysis. It's a view shed. Then also S3M layer have other functions. Now we can explain there are too many words. We can explore the functions in with examples. Also, you can learn the iDesktop for 3D for WebGL with these resources. Can download the package in our official website, and here are a lot of online examples. And also have the API documentation. And also, then if you want to have a full-featured application, then we have the product called SuperMap iEarth. Then that one you could download from our GitHub, SuperMap GitHub. Then you could find the SuperMap iEarth package for English. For SuperMap iEarth, then you don't need to create it helps you to create 3D applications, and you also can extend the functions based on SuperMap iEarth. This is SuperMap iEarth link. And you can see here we add a lot of functions, like add a 3D layer and change the base map, 3D analysis. So I think that I'll show you how to download the SuperMap iClient. So here is our download link. Go to supermap.com. Here support, you can download, and online help. And here you can download iServer, iPortal, and iClient 10i. Here you just iClient is ready for WebGL. And download this package. Here. See? Then you can copy it to your iServer under the web apps folder. And select in the web folder, you have you have two main folders, build folder and example folder. For build folder, then here is have the system source code and the other source code. And here has some documentation, and you could check the API documentation. This in this folder, and also all the examples are in this folder. Then you could try to learn how to create 3D applications with these examples. This is WebClient. Here is the WebGL examples. We can go to this is WebGL page. So here is the API documentation. So you can check every APIs, how to use this API. Now I can sample codes. So here are a lot of sample examples to help you have a tell you how to use these APIs, and then you can create your 3D application with these examples. So before the development, what we should prepare first, of course, is the data preparation, 3D data producing in iDesktop, and the 3D service publishing on iServer. So for the 3D data producing, we have to, first one, we have to configure the 3D workspace and generate the catch file, because we said that only the web application can parse the catch data. So we will produce the S3M data for the 3D models, like beam model, oblique photogrammetry model, 3D Max model, and vec data, and also create a catch file for terrain and image data with TIN and ICS3D format. And for 3D service publish, also this is 3D service resolution. We have to publish a raster 3D service, and the service like this. I will show you in real case. And the link, if we want to add the service layer, what the link should be look like. So all the service should stop in config for 3D service, and for image and terrain data, we will stop and in layer name. So here, how to realize 3D data loading function. First, we have to create a HTML page that should include the script library and add the container of the 3D thing, like we have the map element for map object. And then we need to retrieve the 3D objects, so the 3D service, and then add the 3D layer to the map, to the thing. First is to add the reference libraries that because we in the iClient 3D for WebGL, we will use a season. So we have to add the script library for season and Zilly. In our products, we already set all the paths in main.js. So you just need to following up the structure of these folders. Then just you claim the main.js in your project. So you have to copy the build and the JS folders under the examples folder to your project folder. Then just claim the JS main as. And if you want to modify the path of the season, then you have to modify it in main.js. Then next step is to create the HTML file. First create head and body part, and add a reference library, script library. For this, we have to add a CSS file that defines the styles of the globe, season globe. So we have to add this CSS files, claim this like this, and add the JS requirement in JS, and add claim the main.js. Next is add container for 3D scene. So first we have add div element for 3D scene. Here is a scene container. There's an ID scene container set to width and height. Here you can see in the script that you have to, because this is fixed function for season, you have to write this function, unload function before you write codes, before you start to add the data, add the map to season viewer. First is we create a map in leaflet. Here we have to create claims of viewer, season viewer beforehand. Now we can add all the 3D objects to the viewer. So the new season dot viewer, and the scene container is the div ID that we made for the 3D scene. So after we get a viewer, the container for the globe, now we have to add the scene. So we have to create variable called scene, viewer.scene. Then next step, we can add the 3D data to the scene. So we will use, because for S3M models, then we could use the scene.s3m tiles layer by SCP, and the URL is a service link, 3D service link, like this. So this is one 3D models link config. So when we have to here, but this one scene.add S3m tile layer by SCP, this URL, and you can set a name. It's a promise, so it's a record variable. So if we want to operate these layers, the layers want to do some operations with added layer, we have to use the record function, season.win promise. So that means when we get the data from this URL, we will start do the following operations in this function, and the function and the layer is that this layer means we added through this URL. Then next step is scene.camera.setView. So when we already get a layer data, already add a layer in this in 3D scene. So we have to set our camera view, set the whole 3D because it's a 3D globe. Then we have to know where is the layer located. So you have to set a destination, the camera destination, to go to this season calculation from degrees. Because in WebGL and in Season below, it's a default coordinate system as Cartesian coordinate system. So it's different with degree. So if we want to set our coordinates from degrees, we have to use this from degrees, which should convert the degrees to Cartesian coordinates. And this is where the models located. We have 3 parameters: longitude, latitude, and height, altitude. That defines the camera's views, where the camera views like the viewpoint of the globe. And this function E means if there is an error, what they do, and there will be a learning error message. That's the functions. Then I will show you how to do this. So first, I will show you how to do that. Let's say an example. So we have get the models, 3D models. You also can have these models in sample data. These are models layers. Then we add these models, because now they are just a manual model, 3D Max model. They are vector data now. They are not catch file. This is 3D models. So we have to save it as a 3D thing. Save it as a thing, 3D thing. The building CVD. Then after create this thing, 3D model, 3D thing, we have to create a thing catch, and we will get a catch file. So when we generate a catch file, we will close the thing, because generating catch file will occupy a lot of memories. Here we can select I3M and I3MB. Now for I3MB is a I3M byte, means it's a developed format, I3MB. But for our beginner, we just try I3M. Then we click generate. And here I already generate one. So when you generate catch file, then you will get the SXWU workspace, and includes all the models you create in original thing. You can see that when you convert it to I3M, convert it to catch file, the rendering performance is much more smooth. So usually when you just load the original models, it will take more time to move the main models, operate the models. So that's the advantage of some layer. So when we get this catch layer, catch file, we save it as workspace, then we close it. And we can start to publish the service, 3D services in iServer. I need to log in. Here we can quickly publish services, publish the service by workspace, but you also can publish by others format and like tiles, streaming processing model, and the cloud service or REST map service, but usually we will just use the workspace to publish. And select the workspace that we created in generating catch file. This one. SXW that we generate in iDesktop. Select next. And choose 3D service. Like say what we selected in iClient for JavaScript or the iServer, and we publish the map service and the data service here because we only selected select next. And also you can see here are a lot of service that you can publish. So it supports the ArcGIS REST service, OGC service, and spatial analysis service. But you could see that if you don't have the related data set in the workspace, you cannot publish this service. So next, finish. So after when we finish this, and we will get our 3D services. This is a service link. We will go to real space. Here we can see our things. So in our things, we have multiple layers that we check in here. So if we want to add one layer, we also can add the whole thing. But let's start it with add one layer. One layer that we so here for the thing that we can have a preview of the published the whole service, a whole thing. So this is a preview. Preview in iServer, then you can get this. And now, if we want to go to add the one layer, now we have to go to the data to get the layer link, like a building. Get configuration file of 3D data. That's this link that we will use for the project as a layer URL. So I also create a getting started .html in SuperMap iClient for WebGL. So here in the head part, what need to claim? Of course, the title and metadata, and the CSS file. And here some config JS that the URL will be used in this map. And the main JS file. This one, the main JS CSS, and if you will use a jQuery, and this one is also necessary. And the pretty CSS also defines some object elements in this in this project. Then here is the system container that a div to for the system globe. So this one is also very necessary. You cannot ignore. Then it's our main part, function unload system. The first create a viewer. It's always the first step to claim the viewer. New system.viewer, this is a div ID. Then this one means to add the imagery layers. Viewer at in base map, we can set the bin map as the base map. This is a bin map URL and this map style. And also because bin map, we need to have a key. So we have to set up the key. So what is mean? It's a variable in config. We can see that here I have a config.js in JS. Config.js. So here are lots of config because we will use many URLs in our examples. So we will just create such JS file to store to claim all the URL that will be used in the examples. So this is URL and map key, bin map key. The next is to claim the scene. Now we can add the 3D layers in scene. So I already said that we could have in this example, we use the add S3M layer by SCP. Let's just add one layer. So, but usually our 3D scenes includes multiple layers. So here, we will use use the scene.open to load all the layer, to load the whole scene, not only just one layer. But let's see another example how to add one layers. Scene.open. Here is add S3M by SCP. Here. Can just copy, add S3M layer by SCP. This URL is the layer URL, and we can set its name. Here is the promise that function layer is a record function. When we get a layer, then we will set a view, the destination. Here we can set the condition coordinates. And also here as destination orientation, because 3D, like we have the camera, we have its destination, but we also have other parameter orientation, like heading, pitch, roll of the camera to adjust our view from the different angles. It has set orientation. So this is already set for this, then we could have, okay, copy this. Okay. Delete this. Now we see here URL dot, copy this link. CBD building. For this, I think should set the call. Should set the destination condition from degrees. So we used set. Okay. You can get the coordinates in iDesktop. Yeah. Delete this. Yeah, I think that's, we can try to run this. SuperMap in and getting started. I miss the examples. Wait a moment. So I will teach you if there's for some debugging skills, then for Google Chrome, you can use F12 to start the debugging page. Then you can see console. If there is any problem, any error, you can see from the console. And so network or source, so network, you can see the resource recalling, resource downloading. You can see which resource will cost more time for downloading. And also you can see the source code in debugging page. So if there is any problem, so if you meet any problem, you can stop. You can debugging at maybe the line will have problem. So we see. Here's some. This one is okay. Set to the. Oh, it's a wrong place. I set. It should be in China. I set. So this happens because the wrong coordinates. Okay. Can see these examples to see the things. This one, CBD. HTML. Data is still loading its same location. So the result is like this. I think it's, yeah, it's here. That's a visualization result of the CBD dataset. Here, I think you also can get, if you want to change the start viewpoint. Here you can claim the viewer. Yeah. This is, I think it is for advanced. So you can do some debugging in the source code at some breakpoint. Here you can see the camera parameters through debugging, and then you can adjust the preview, the set view destination. And here some functions like click to rotate. Can rotate the, like say you click to choose the one object, then you can rotate this thing. So you can stop rotation. So here are a lot of examples that we could follow. Let's see the examples. We can add oblique photogrammetry model and beam model, vector mode point cloud. In the sample code page, you also can check the source code. And here is a source code editor on the side. And if you modify the code here, then you can run to see the difference. Yeah.
Hello, Amber.
Hello. I don't. Yeah. And sorry that I click the stop sharing. And except the supporting multiple layers, multiple source of data, what you could do and more with iClient, like say here is some dynamic layers at global flight and globe shipment dynamic and traffic simulation. But, it will take some time. This also CBD. This also work. This example also for CBD. And let's see something interesting. And you can do also circle query, spatial query, and dynamic simulation for 3D objects, and so do a lot of 3D analysis, like visual analysis and visibility analysis, view shadow analysis, skyline profile analysis, and clip polygon. Here are some many interesting analysis and you could follow. And here you can add animated model like the GLT and the 3D Max model and make an animation with that. So at the this one you can add create the 3D thing and some models like recycle bin and add different tree into your 3D thing and make some visualization. Example this is an air quality map. And here are some particle effects like a fountain or fire. So here some streaming. You also can access the streaming data service to make the real-time map. See here some other special effects for like the trail line and night thing, some night source. So I have the plotting. The zoom window. Just annoying. So this is a case of the traffic simulation. You can see this one we can access the real-time traffic surveys from traffic management government. Then we can simulate a real traffic situation in 3D thing. Of course, this is a simulated data, sample data from traffic government, and we can see the cars. Yeah. So I think that's all for today's training.